Number 9 on the far left of the page, I can read it to you. If you can't read
Yeah,
it.
I can kind of, let's see, that looks like 6x squared plus what, 19x?
17x.
17x plus 5. All right, and these are all factoring problems.
Mm-hmm.
All right, these are definitely the more difficult kind of factoring problems because this 6 is not a 1. Okay, that by definition makes it more difficult. How am I going to split up the 6x squared?
Um, 3 by 2x.
That's where I would start. I don't know that that's the right answer. It may be 6 by 1, but I'm going to start with 3 and 2. Next step.
Um, plus or minus.
How can you possibly produce a
Oh,
5?
it's plus. Sorry.
Plus in both cases. Now it's either 1 and 5 or 5 and 1. Well, let's try 1 and 5.
That's
After
it.
you do enough of these, you should in your head be already multiplying the insides and the outsides together to see if that produces 17x. In other words, when you're doing these higher level quadratics, to determine which factors to use, you really have to do this to even determine it. Well, that's plus 2x and that's plus 15x, so that gives you the middle term. That's got to be the correct answer. Okay? In other words, this process that I call double smiley face kind of,
Mm-hmm.
that's not just a checking process. That is a process that you have to do to determine the answer. In other words, let's say I randomly said 1 over here and 5 over there. Let's say I said 5 there and 1 there. Well, now you have to check, does that produce it? And the answer is no. Okay? So I have to try the other. The only other alternative is 1 and 5. And if that doesn't work, then I got to go back and change this to 6x and x. In other words, you have to try all the possibilities.
Okay.
Next one looks like 9x squared minus 1. Looks like you've done that correctly. How's that factor?
3x minus 1 times 3x plus 1.
Next one, 10x squared
Mm-hmm.
minus 3x minus 1. Get me started here.
5x and 2x.
That's where I'd start. Doesn't mean it's right, but that's where I'm starting. What are the signs?
Positive, negative.
And because the 5 is different than the 2, I got to do the positive negative like this.
Mm-hmm.
Well, there's only one set of factors for 1, so I'm going to start off trying that. Does that work?
No.
Hold on. How do you
Oh,
test?
yeah, it does. Yeah, it does. Sorry. I was looking.
I want you, in other words, part of the process is determining if that works. So you always have to do that. And that does work. And
Mm-hmm.
I was just lucky. I got it on my first try. I didn't have any thought that that would work because I could have tried minus 1 over here and plus 1 over there as a place to start. That would not have worked, but all right, this one looks like 6x squared minus 13x plus 2.
Mm-hmm.
Okay.
Let's say it's 6x and x.
It's not where you would start,
Well,
right?
you'd start at 3x and 2x.
That's where you would start. But then you quickly realize that both signs have to be negative. And even if I put the 2 there, I don't get to 13. Okay? So, and obviously if I put the 1 here, I'm going to get to a smaller middle term. So I know right away that I got to go back here and try 6x and x. And now I can see that if I have a minus 2 over there and a minus 1 there, does that give me the right middle term?
Mm-hmm.
It does indeed. Solve the equation. Looks like you've done 13, is that right?
Yep.
Let's do 14. The only difference between solving and factoring is a very minor one. In other words, we still have to factor. It's just that then we have to do more stuff to solve. We have to set each factor equal to 0 in order to solve it. Okay? Let's go through the 3 steps with me here.
All right, so you have 3x and x.
That's the only choice.
It's plus minus.
No.
Oh, it's double negative, sorry.
Okay.
And your only factors are 5 and 1.
So which way should I try first?
5 with the 3 and 1 with the x.
Yeah, and that quickly produces the correct middle term. In other words, you still have to do this step because unless you can do that in your head, I can't do it. I have to write it out, and then I know I have the right middle term. Okay? Number 15, 25x squared plus 20x plus 4.
Yeah.
Okay.
5x and 5x.
Again, it doesn't have to be that. It could be 25 and 1.
Yeah.
Both sides?
Positive, positive.
Factors of 4.
Factors of 4 are 2 and 2 and 4 and 1.
Which one should I try first?
2 and 2.
That works. Now, go ahead and finish solving this. In other words, if that times that is equal to 0, what's my solution?
In your solution,
Set that equal to 0.
okay.
That's how you do.
You have,
Set both of them equal to 0, but in this case, they're both the same.
yeah, so
So we can get our solution by just setting one of them equal to 0. Let's actually
that's
equals what?
2/5.
Negative.
Negative. Oh, yeah, okay, yeah.
Okay. Looks like you did 17 and 18. Okay. 17, you have to move that 21 over to the left side, and then you solved it correctly. 18 is difference of perfect squares. That's how you're going to factor it. Let's look at 19. Go ahead. Do these step by step.
So you have 2x and x. Plus minus.
Which means plus minus or minus plus.
Mm-hmm. And then either 2 and 2 or 4 and 1.
Okay. Now think about 2 and 2 for a moment. Can it work?
No.
No. You're never getting up to 7, right?
Yeah.
In other words, you're going to have 2 times 2, which is 4, and 2 times 1, which is 2. The best I can ever get to would be 6, and that's if they were both the same sign. So it's not going to be 2 and 2, which means the only other possibility is 4 and 1. Where's the 4 go? Where's the 1 go?
4 goes with the x, the 1 goes with the 2x.
And the 4 goes with
awesome.
the plus sign. The 1 goes there, and of course that gives you minus x and plus 8x, which gives you 7x. Okay. These are all quadratics. You can't quite read the exponent. Whoops.
Yeah, these are all quadratics.
Plus 32 equals 0.
So it's x.
Step 2.
It's minus x minus x.
It's not minus 6 minus 6. In other words, there's a problem when you try to do it all in one step, Cole.
8 and 4. So.
Yeah, you see what the problem is when you try to do it all together?
Mm-hmm.
In other words, I've now done 2 steps. I've got it x and x, and I got both signs figured out. Now the next step has to be factors of 32, which are not 6 and 6. 8 and 4 is correct. You may have to read 21 to me.
8x squared plus 5x minus 4 equals 2x squared minus 8x plus 1.
Okay, tell me how to solve this.
Get everything on one side of the equation, so subtract the 2x, add the 8x, and subtract the 1.
Okay, what's that give you?
That gives you 6x squared plus 13x minus 5 equals 0.
0. Go ahead. Start me
Start
out.
with 3x and 2x. Then your factors of 5 are 5 and 1.
Okay, first of all, we're going to figure out the signs.
Plus, minus, or negative.
Or minus plus. We only have one set of factors, and we have to get all the way up to 13. Well, I would put the bigger of those factors on the right side with the plus sign. That's where I would start, knowing that I have to get to a pretty big number. Okay, well, if that's a good place to start, then there's only one choice there, and you'll notice that works right away.
Mm-hmm.
In other words, sometimes you don't necessarily have to go just randomly. In other words, I know that if I put my 5 over here in any manner, well, that's going to give me 10x, but then I got to subtract 3x from that. So that can't work. And I could try it and figure it out pretty immediately, but a lot of times, especially once you get used to doing these, you'll see that how to do them almost without trying them randomly. You can always try them randomly. There's nothing wrong with that. But sometimes when you get good at them, you don't have to try them randomly. You know exactly where it's going to go. I suppose that comes with practice more than anything else. 22, let's see, we got 4x squared plus 10x equals x squared minus x plus.
Mm-hmm.
Okay, what's the next line?
3x squared plus 11x minus 4.
Equals 0. That's an important part of it.
So you have 3x and x. Either plus minus or minus plus.
Good. Now, again, I got to get up to 11.
Yeah, so I'm going to say that it's 4 and 1.
Yeah, it's not going to be 2 and 2. It's impossible to get to 11 if I use 2 and 2. So you're right. And the 4 has to go with the plus sign.
Mm-hmm.
Because I need to get up to plus 11. Which means the 1 goes with the minus sign, and that works.
Mm-hmm.
So this actually becomes a little bit more than just trial and error. When you do some of these higher level quadratics, you get pretty good pretty quick at figuring out which factors of 4 to use. In other words, not starting with 2 and 2.
Mm-hmm.
All right, let's see. Did you send me a second picture?
Yeah, I did. No, it's just the top part, just simplifying radicals.
Yeah, I got it. All right. Now let's look at the first one. It's not that there's anything wrong with the way you did it. What you did basically was square root of 4 times square root of 8, which is 2 square roots of 8. And then the problem is that simplifies further. All right, I don't have any qualms with the way you did it. Let's look at the second one. Notice that you could have gone a little faster if you'd have noticed 16 as a factor of 32.
Yeah.
In other words, if you notice that it's 16 times 2, you get there immediately in one step. Now, you can do this the hard way, which is 2 times the square root of 324. But that really is the hard way, and if you don't have a calculator, figuring out the square root of 324 could be tough. There's a better way to go.
54 is 9 by 6.
Yeah, that's the better way to go, which is 3 root 6 times 2 root 6. What's the answer to that?
6 by 6 is 36.
Very good. Square root of 147. Is that divisible by 3 or 9? And I say that because it's definitely not divisible by an even number. It's not divisible by 5. I don't think, oh, it is divisible by 7. But the reason you know it's divisible by 3 is because the digits add up to a number that is divisible by 3. They add up to 12. 1, 4, and 7. So the moment they add up to 12, you know it's divisible by 3. Okay? Well, if you divide that by 3, what do you get? You get the first number is
3 by 40.
What is it?
3 by 49.
And that, of course, becomes 7 root 3. Again, the hard way would be to say that's that. Okay?
Mm-hmm.
Because all I've done is just created a big number I got to deal with. Better if we see if we can break this down into something common. In other words, what I want is a common root. Well, how would I, if I factor each one of them, 10 factors how?
10 factors into 5 and 2, and 15 factors into 5 and 3, so your common radical would be 5.
And it's not so much that I'm looking for a common one. I'm really not. The beauty is that because I do have a common one, I can multiply that by that, and it's equal to 5. And now if I multiply that by that, it's equal to root 6. And that simplifies it. In other words, notice how much easier that is than trying to break down root 150.
Mm-hmm.
Now, just make sure, I mean, I know you probably know this, but when you see an expression like that, it just means the same as this. In other words, two numbers being next to one another or multiplying one another with or without the dot. So the dot doesn't really change anything. I don't need it even in the beginning. If that dot wasn't there, it would be the same problem. Let's do, since we just have a few minutes left, let's do some of the harder ones. 28. It's the first step. Always remember that this is equal to this.
Yeah.
So that's almost always the first step when you have a square root of a fraction, is to split it up into its various fractions like that. Now, what can I do on the top?
Don't you want to get the radical out of the denominator on both of those?
I'm sorry, what?
Don't you want to get the radical out of the denominator?
Yeah, that happens immediately. As soon as I multiply those two together, I get a 3.
Oh, yeah,
How do
okay.
you handle the numerator?
Let's multiply it, so it'd be 7 by 14.
Well, I could write it as square root of 98, but there's an easier way. Can you break down 14 at all?
Oh, so 7 by 7 root 2. 7 by root 2, sorry.
Yeah. And notice that this is a number that you would not normally simplify. In other words, if I gave you root 14, that's the answer. You don't want to simplify that into root 7 times root 2. That's 2 terms instead of 1. But in this particular problem, simplifying it makes the whole thing easier because we're multiplying it by something. So sometimes you do want to simplify it even if you wouldn't normally. Well, yeah, I like this one. Do that one.
So you can simplify 27.
Well, first of all, do this. And now, what we're kind of looking for at this point is, can we find a common root? If I break apart the top, what do I get?
4 and 3.
So that's root 4 times root 3, or 2 root 3. If I break apart the bottom, what do I get?
3 root 3 at the bottom.
I'm sorry, what?
Bottom is 3 root 3.
And now the root 3's cancel, and you're left with that as an answer. 2/3. I'm going to make one up because it's one you run into quite a bit. And this gives everybody problems. So do this the same way we've done them.
All right, so you have root 1 over root 2.
Which is 1 over root 2. And now what do you have to do to that to make it look legitimate?
Multiply top and bottom by root 2.
Which gives you root 2 over 2. Okay, so this one, a lot of times you get this as an answer, and if you don't convert it into 1 over root 2, you don't notice that you have a radical in the denominator. So this is a big step right here, because now that's what tells you you have to rationalize it.
Okay.
Okay. 34.
So you have 12 root 5. So you have root 12 over root 5.
That's always what you want to do as a first step, no matter what.
So multiply the top and bottom by root 5.
Okay, which gives you what?
So that'll give you root 60 over 5.
Now, can that be simplified? Is there a way to pull a perfect square number out of that?
No.
About 4.
Oh, yeah. Okay.
So that's 2 root 15 over 5. And that's your answer. In other words, I could break down the root 15 further, but there's no advantage in doing it. It becomes root 5 times root 3, and there's no other root 5 anywhere. So I wouldn't do that. Cole, you good to go?
Yep, I am.
All right, have a good week. I'll talk to you next week.
Talk to you next week.